So now we get to do some fun word problems and picture rectangle problems. These are classic Algebra 1 problems. You're going to see these again and again. So I hope you enjoy them. They're fun, I think. So before we actually dive into the picture that's on the page, I want to kind of review just the idea of area. And this is real basic, but sometimes we kind of forget to talk about it in these terms. So if I have the dimension of 2 on this side and the dimension of 4 on this side, I can talk about the area that this covers by counting these little squares. So the area is 1, 2, 3, 4, 1, 2, 3, 4. The area is 8. Well, of course, instead of drawing pictures, we like to find formulas and find easier ways to do that. And we introduced the formula of length times width. And in this case, we could say our length was 4, our width was 2. It doesn't really matter which you call what. And our area is 8, and it's square units because we've counted these squares. It's two-dimensional. We've got a length and a width, and we have square units as our answer. So let's go down here and look at what they're asking us to do. Up at the top, they're saying find the area of the shaded region. So in this first big rectangle, you can see that the shaded region is this little interior rectangle, and we've got a large exterior rectangle and a bunch of dimensions. So if we want to find the area of this guy right here, we need to use our formula, length, which is this guy, times width. But they don't give me this length and this width, and I can't count the squares because they're too hard. It's too hard to count the squares. So we're going to have to figure out a way to figure out what the dimensions are for this little shaded rectangle. And the information that they give us in the picture is going to help us. They tell us, show us, I guess, that the length of the large rectangle is 10. And they give us some information about from this side to our little rectangle, and from here to here is 3. Well, it stands to reason that if the whole thing is 10, and you've got this piece being 3, and this piece being 3, that's 6. So that means our dimension for this side of our rectangle is going to have to be 4 to get back to 10. 3 plus 4 plus 3 gives you the 10. Same thing with the 8. You have the dimension of 3, and you have the dimension of 3. That's 6. When you take those 6 away, this side is going to end up being 2. So now we're ready to just plug in our formula. Area is length times width. Area is 4 times 2. Area is 8, and it's square centimeters. So you can either write it like this, or you can write it this way. But it is not 8 square centimeters, because 8 squared is 64. So either one of these ways is great. All right, let's look at the bottom one. I want to look at that one really in tandem with this one because these have the same measurements. So really what they're asking you to do, you can see this is 8 by 10, this is 8 by 10, 3, 3, 3, 3, 3. So the exact same measurements. So we can use what we found in our first problem. We can use this 8 square centimeters to help us figure out what the area of the shaded one is in this bottom picture. So if this area, I don't like the fat pen, I like the skinny pen. If this area is 8, then if we find the area of the entire big rectangle and subtract out this little bitty guy, it's like we cut a hole, cut him out, that will give us the area of the shaded part that's left over. So that's what we're going to do. So area of the largest rectangle, length times width, which is 10 times 8, which is 80 square centimeters, minus the 8 that we're going to cut out, square centimeters, is going to leave us area of the shaded area of 72 square centimeters. And that's going to be our answer. So let's go to the next page really quickly. We've got a binomial now. That was just the page before was just all numbers. We didn't have any variables in there. But we're going to do the same thing with our binomial. So our idea is we want the area, again, of the shaded region. The shaded region is this blue shaded area. And we are going to use the same idea. We are going to find the area of the larger rectangle, and we're going to subtract out the area of the smaller rectangle, and that is going to give us area of the shaded region. So this is kind of our verbal model. This is what our plan is. And now we have the dimensions. We just have to plug them in our idea here. So we're going to say the area is the length times the width of the larger rectangle, this guy, length times width. So he is 3x times 8x plus 2. And we are going to subtract out, to get this guy right here, we are going to subtract out the area of the smaller region, which is x times 3x minus 4. Of course, now we've got distribution and collecting like terms. We've got to clean this up. So when we distribute, we get 24x squared plus 6x minus 3x squared plus 4x. So I'm looking for like terms, always, always, always. I've got some x squares here and some x squares here. If I take 24 of them and subtract out 3, that leaves me with 21x squared. And then we have some x to the first powers hanging out, and they're positive. We have 10 of those, and I have no constants. So I've pretty much used up all my terms, and this is going to be my simplified answer for, this is the area of the shaded rectangle is equal to this square units, whatever the units are. That's our answer. Thanks for listening.